The fundamental, it's too long to write. The fundamental theorem of calculus, part 2. Okay, to find the area under a graph, that's what we've been doing with integration and a lot of the things in this unit. But to find the area under a graph that's a little more flexible, a little more open, consider the area from 3, so it's like a definite integral, but up to x. I don't know how far to go. And we'll take a relatively easy function. We'll use f of t is equal to t squared. I don't use x because I've used x as my upper limit. Let's just take a look at what that would look like. So we'll get an area function, and the area with respect to x will be from 3 to x is integral of t squared dt. And if we use what we learned last day, well, that's t cubed over 3 integrated from 3 up to x. And by substitution, that becomes x cubed over 3 minus 3 cubed over 3, or x cubed minus 27, all divided by 3. And you should notice that if we take the derivative with respect to x of x cubed minus 27 over 3, we'll end up back at x squared. And that's always true with integrals and differentiation. So it's always true that the derivative of the integral is that original function. Let's put that down formally. So first of all, we'll start off with f being continuous on an open interval, and it has to contain the value a. For every x in the interval, this is true, that if you take the derivative of the integral from a to x of your function, and we'll write it in terms of another variable t, you will always get, as I showed above, that original function with respect to x. And this is known as the fundamental theorem of calculus, part 2. Here's an example of it in use. If we wanted to find the derivative of the area function, which is equal to the integral from 2 to x of 1 plus t cubed dt, I should just be able to take this f of t function and substitute in an x. And that's exactly what I get when I take the derivative. Because there's an integral, the derivative sort of cancels out that integral, and I get 1 plus x cubed. This does get a little bit more difficult, of course, so let's take a look at another example where it isn't quite as straightforward. The derivative of this function, which is a definite integral from pi over 2 to x cubed of cos t dt, and you would think that using the fundamental theorem of calculus part 2 we could simply get cos x. However, that's not true because the fundamental theorem of calculus requires that this upper bound be an x. So, there's a couple different ways to attack this. One of them is to use the chain rule. So let's take a look at that method first. So the first way that you could attack this is you could create a new function called g of x, and you could say when I have g of x, I'm going to substitute in that x cubed, not x sub 3, x cubed in for x. And that will give me my function pi over 2 to x cubed of cos t dt. And if I were to take the derivative of g of x, I get the derivative of x cubed, but now I have to take the derivative of the x cubed part as well. So I have to multiply this by what's the derivative of x cubed, and that tells me that I'm actually multiplying by 3x squared. So now when I evaluate f prime with the x cubed in there, yeah, I get cos x cubed, but I also get 3x squared that's multiplied by it. Another way to do this same question is using another trick. It's very similar to this first method, which is basically the chain rule, and it's called substitution. So let's take a look at that. If you make the x cubed a new variable called u, then your f of x is the same as f of u, which is from pi over 2 to u of cos t dt. But when you take the derivative of your f of x function, you're really taking the derivative of u times the derivative with respect to x of u. And the only way to calculate this little piece is to find out, that's u prime, is to find out what the derivative of this one is. So you're going to have to take the derivative with respect to x of this one. And if you take the derivative, you get du dx, or u prime, is equal to 3x squared. And so you get that u substituted in, which is cos, and u is x cubed, so you end up getting cos u times 3x squared, and as I said, that u is x cubed times 3x squared. So then you back substitute and put that u back in. We're going to do this method, it's called substitution, a lot more later, so it's good to have seen it for the first time now. Okay, so hopefully FTC 2 makes a little bit of sense to you, and you can come to class ready to try some questions. See you then.